Hey guys, so today we're going to be going through differentiation, the second part for add maths. And so last video we were talking about how at the beginning we were talking about how you can use differentiation to find the gradient of a tangent. Of a function at a point, right? And obviously we've seen in extended maths that to find the gradient of a function at a point is you draw a tangent to it, right? So yeah, so the way to find the gradient of a function at a point is to find the gradient of the tangent. Okay, so differentiating a function allows you to get the gradient equation of a function at a point, and therefore allows you to find the tangent of a function at a point. And obviously the normal would be perpendicular to the tangent at that specific point, right? So find the gradient. So let's look at an example here. So find the gradients of the tangent and the normal to the function y equals x squared plus 4x plus 4 at the point 3 comma 25. Okay, so your equation is y equals x squared plus 4x plus 4, right? And first of all, you need to differentiate this. So dy over dx would equal 2x plus 4, right? And after this, right, to find the gradient of the tangent, right, you would take that x value from that point, which is from the 3 comma 25. The x value would be 3, and you just substitute that into the differentiated function, right? So then you take the x and you put it where you see x. So 2, 3 plus 4, which is just 6 plus 4, which is 10. And that's it. You found your gradient of your tangent. And to find the gradient of the normal, it's just as you know, the normal is perpendicular to the tangent, and you know that two perpendicular lines, when you multiply their gradients, it should equal -1, right? So obviously you have the gradient of the tangent and then times x for the gradient of the normal, just and both of them multiplied should equal -1, right? So that means your x, which is the gradient of the normal, should equal -1 over 10. And yep, so now you have your gradient of your tangent and your normal. And that's just the easiest way of doing it. And that's it for gradients, tangents, and normals. Okay, so next thing we need to go through is stationary points. And so the way to look at stationary points is, the stationary point is basically like the bottom of a curve, right? The turning point, right? And obviously at this point the gradient is 0, as you can see. And so you can have a maximum point and a minimum point, right, where it's turning, because you can see the diagram on the left. It goes down and it goes up, and it will never go down lower than that. So as you can see, that's a minimum point, because you can see that's the lowest point on the curve. And that's what you can find with stationary points, is after you find the stationary point, they might ask you to find whether it's a maximum point or a minimum point. And the way to find a maximum or minimum is by using the second derivative. So if your d2y over dx2 is greater than 0, then it's a minimum. And if your d2y over dx2 is less than 0, then it's a maximum. It's just as easy as that. So the best way to visualize this is by doing a question. Find the stationary point on the curve y equals -x squared plus 4x plus 5, and state whether this is a maximum or a minimum. Okay, so you have your equation, which is -x squared plus 4x plus 5. And the first thing you need to do is differentiate this. So your dy over dx would equal minus 2x plus 4, right? And after this, we know that the gradient of the function at the stationary point is 0, right? So all you need to do is make this differentiated function equal to 0, and you just basically just solve for x. So that's minus 2x equals minus 4, and x should equal 2 from there. And that's your x coordinate for the stationary point. And you can see that we have the x coordinate, but we don't have the y coordinate. And the one thing you should do for finding the y coordinate is taking that x value, the x equals 2, and substituting it into the main function. At the top, the y equals minus x squared plus 4x plus 5, and that'll give you the y value for the coordinate. And if you substitute x equals 2 into the main function, you should get minus 4 plus 4 times 2, that's 8, plus 5, that should give you 9. So that means your y coordinate should be 9, and that's your stationary point. It's as easy as that. And next thing we need to know is whether it's a maximum or a minimum, right? So your d2y over dx2, you get it by differentiating the differentiated function. So your d2y over dx2 should be minus 2 because we're differentiating this. And as you can see, negative 2, that's negative, right? So that's less than 0. And as you can see that if it's less than 0, then it's a maximum, right? So now we know that it's a stationary point. There's a stationary point at 2, 9, and it's a maximum point, right? And yeah, that's it for that question. Once you get the concept, it should be quite easy. That's I'm not gonna say anything. But I think it should be quite easy. Alright, so the next thing is small increments. So the main formula is delta y equals dy over dx times delta x. Okay, so as you can see that this delta is a lowercase delta. It's not the main delta, which is a triangle. So this kind of tells you that it's a small change of y and a small change of x, right? So basically, you use it in questions where they ask you to find the change in y when there's a change in x. So let's look at this example for find the small change in y in the equation y equals x squared plus 4x plus 4, where x changes from 2 to 2.02, okay? So we have our x, and it goes from 2 to 2.02. So that means our small change in x is 2.02 minus 2, which is 0.02. So we have that part of the equation, and our dy over dx should be 2x plus 4, right? And we need a number for dy over dx, right? We can't just have x lying around in there, because then we can't find the change in y properly. So the value that we substitute into this x over here is the original value of the x, right, which is 2. So what we do is we take the 2 and we substitute x equals 2 into the x, and we say plus 4, which is 2 times 2 is 4 plus 4, that's 8. And yeah, that's your dy over dx, and that's all you need for this equation. So now we can see that the delta y equals 8, which is dy over dx, times the change in x, which is 0.02, which is 0.16. That's your change in y. And you can give a different variant of this question, which is find the new value of y, right? like after it's changed. So the way to do it is to take this original value of x and you substitute it into the main equation, right? The y equals x squared plus 4x plus 4, right? So then doing that should give you y equals 2 squared plus 4 times 2 plus 4, which is 4 plus 8 plus 4, which is 16, right? So that's the original value of your y. And you know that y changed by 0.16. So then your new value of y should equal 16 plus 0.16, which is 16.16. That's your new value of y. And yeah, that's that for small increments. And okay, so the last part of this topic is connected rates of change. Okay, so the best way to go about this is by doing an example. And so a circular stain is spreading so that its radius increases at a constant rate of 3 millimeters per second. Find the rate at which the area is increasing when the radius is 50 millimeters, right? Okay, so basically we're looking at the rate at which the area is increasing with time, right? So that means we're trying to find dA over dt, right? But they gave us dr over dt, right? Which is 3 millimeters per second, right? And we know that the original value of r is 50, okay? So how do we link dA over dt with dr over dt? And we know that the area, right? The area of a circle is pi r squared, okay? So now you can see that if we differentiate this and we find dA over dr, we can say that dA over dt equals dA over dr times dr over dt, and this way the dr's cancel out and you're left with dA over dt, right? So what you do is you differentiate this equation right here and you say dA over dr equals 2 pi r, right? So that's your dA over dr. And to get a number for dA over dr, instead of putting it in terms of r, is you take this original value of r and you just substitute it into here. So you have 2 pi times 50, which is 100 pi, okay? So that's your dA over dr. And I just put it in terms of pi so that it'll be more accurate when we get the final answer. So then now we just plug it into the equation. So dA over dt equals 100 pi, which is your dA over dr, times 3, which is your dr over dt, which is 300 pi. And you just leave it as like that. If you want to keep it, if they ask for an exact value, right? So then this would be 300 pi millimeters squared per second. Or if they want it in decimal form, then it's 300 times pi, which is 942.5, which in 3 significant figures would be 942 millimeters millimeters squared per second. And that's the way to do it. You have to link most of the time you differentiate the main function and you link it, and you try and link it with the, like here with the dA over dt, you're trying to link it with dr over dt by differentiating the function, right? And basically one of the things have to cross out to get the other thing, right? So then over here the dr's cancel out, so then you can get the dA over dt. And Yeah, that's it for differentiation. And thank you for listening, I guess. Um, Goodbye.